so first of all, the first thing to notice is it's quadratic, right?
Right.
And it's a negative in front of x squared. So we know that this is an upside down quadratic, an upside down parabola. So when it says when does it reach its maximum height, aren't we finding this point right here, which is called the vertex? So now if your calculator won't calculate it, and they'll specifically put problems where your calculator won't calculate it, you have to know how to find the vertex using the formula. So the x point of the vertex, the x point is x is equal to negative b over 2a. This is how you find the vertex point, the highest or lowest point. So opposite of b over 2a. So in this problem, the opposite of b would be negative 40 over 2 times a. Now you can't just get lazy and just type that in like that to your calculator. It will calculate it wrong. You need to calculate the top, which there's nothing to do. Then on the bottom we get negative 32. So now you can type it into your calculator. Negative 40 divided by negative 32, you get 1.25. So it says, when does it reach its maximum height? Isn't that after 1.25 seconds? So after 1.25 seconds, and we're done, because it says when. Now what if it would have said, what if I changed it to what is the maximum height? Wouldn't we have had to find this point first, right? The x point. So after 1.25 seconds, it reached its maximum height of, wouldn't we just plug that in, back in wherever there's a t? That's time 1.25 seconds, right? But because of the wording, it says when does it reach its maximum height? It reaches it after 1.25 seconds. We were done. Questions on that? Okay. Let's do the next problem. This one I don't want you to write down, actually. I just want you to look up here. So we have practiced this a lot. This is a problem you will see. But we've practiced this so much. So let's go through and determine if it's linear, quadratic, or exponential. So 1, 2, 3, 4, 5, 6, 7, 8. They're all different. So number 1, linear, quadratic, exponential. Quadratic, it's a U shape. We know it's for sure quadratic. What about this one?
Linear.
It's a line, so it's linear. What about this one?
Exponential.
It starts out exponentially small and gets exponentially smaller, so this one is exponential. Way to remember. Okay, number 4. Quadratic, it's degree 2. Very good. Linear, it's degree 1. Exponential or exponent is a variable, so this one's exponential. Very good. And then number 7. These xy points are they linear, quadratic, or exponential? So if they're linear, won't the differences the first time be the same? Then the differences the second time are the same, that'd be quadratic. If we divide the y values, that would be, and they're the same, it'd be exponential. So let's go do this. 6 minus 3 is?
3.
11 minus 6.
4. 5.
18 minus 7.
7.
18 minus 11. Sorry. I said 18 minus 7. So 18 minus 11. 7. Were they the same the first time?
No.
No, so it's not linear. Let's see if it's quadratic. 5 minus 3.
2.
7 minus 5. So we know it's definitely quadratic, right? They were the same? Okay, number 8. Linear, quadratic, or exponential. Looking at our y values.
Linear.
So 2 minus 1. Now notice I'm taking the y value that comes after the y value before it, right? So 2 minus 1. 3 minus 2. Was it the same the first time? So it's linear. Now once again, if we would have been multiplying by 2 each time, that'd be exponential, right? Everybody? Okay, we're all good? Okay, now write this one down. We've practiced this a lot. Every single one of you will get a problem like this on your final exam. Write something in equal form. So we have these 2 problems. I'll let you get them down and we'll go through it. Okay, so guys, they're quadratic, right? So first, this one's quadratic. So quadratics have the form ax squared plus bx plus c. Now, is it standard form? Isn't there standard form, factored form, and then vertex form of a quadratic? Okay. Okay, guys. So this is in standard form. Quadratics can be written. Are you listening? Because if you're not, then yeah, it's going to be new to you. You can also write it in factored form, right? If it factors, or vertex form. Factored form is easy for me because we're all good at factoring. So let's see if this factors. Because isn't factored the same thing as standard, just different forms? So a times c, what multiplies to be 4, adds up to be negative 4. 2 times 2, negative 2 times negative 2. Good. So then doesn't this, now some of you like the long factor and that's great. I love it. I'm going to just quick factor this one because my a value is 1. So this factors to be x minus 2 times x minus 2, right? So we would put right here x minus 2 squared. Now you guys, that is equal to that. It's something in equal form. Okay? So looking at this next one. X minus 6 squared plus 2. Isn't this in vertex form? Isn't vertex form easy to write in standard form? For the most part. So we know we can rewrite this as x minus 6 times x minus 6. And then we won't forget about our plus 2 out here. So then we'll be distributing x squared minus 6x minus 6x plus 36. And then we cannot forget about our plus 2. Combining like terms, and that's what we'll put as our answer. We'll have an x squared minus 12x, right? Yes.
I have a question. Do you have to write it? Can't you just do x minus 2 and then x minus 2 again?
Yeah, that would probably, I bet they would accept that answer. Yeah. So, good question. Negative 6 minus 6 is negative 12x's, and then we have 36 plus 2, which is 38. So we just rewrote this in standard form, from vertex form to standard form. Questions? Okay, don't miss those. Okay. Don't write down the whole question, just write down this part. So it says, a rectangle garden has a length x as the shorter side. What is the length of the shorter side in yards if the area satisfies the following? So it says the area satisfies the following. X times x plus 3 is equal to 54. Now let's think about these instructions. This is a problem that I saw last year. So let's think about what this problem is like. Let's make sense of this problem. It says x is the shorter side. Doesn't that make sense since x plus 3 would be larger than x by 3? So we know the shorter side's x. Okay, that was a given. X plus 3. Isn't that a length times a width equals an area? So can't we solve for x to know the side? Okay, so we would multiply an x squared plus 3x is equal to 54. Now I have a few people say, but I don't know how to solve that. Well, yeah, you do. If it's a quadratic and it's not missing the x, we have a 3x that's not missing the x. Then you have to get it set equal to 0. So we subtract 54, way to remember that. So we have x squared plus 3x minus 54 is equal to 0. Now you can solve by factoring or the quadratic formula. I always try factoring first because it's way easier than the quadratic formula. Less room for error. So we're looking for what multiplies to be negative 54 and adds up to be 3. If you didn't know, you'd go 54 divided by 2, divided by 3, divided by 4, divided by 5, and then finally you'd get to 6, and you'd say 9 times 6. Didn't have it. Okay, so 9 times 6, and then you said negative 6. So now I'm going to quick factor and if you like to drop and break, that's great. So this will factor to be x plus 9 times x minus 6, but are we done? No, this one we have to solve. So the zero product property rule says since those are factors that are multiplied and set equal to 0, we can set each of them equal to 0 and solve. So x plus 9 is equal to 0, x minus 6 is equal to 0, and solve for x. Subtract 9. X is equal to negative 9, and we'd add 6. Add 6. X is equal to 6. So now for this problem, it says what is the length of the shorter side?
Negative 9.
So would we put in negative 9 though for a side length of a garden? No, so that's why we would throw this answer out. So our answer would be 6, right?
Yeah.
Okay.
Oh, I see.
Right, 6. So our shorter side's 6. Now you can even check your answer. 6, and then 3 plus 6 is?
9.
9 is 6 times 9, 54.
E.
Yep.
E, yeah.
Right. Our length of it. Awesome. Yay. Okay. Next problem. It says, sorry, find the zeros of x squared plus 2x minus 80. Write that down. So find the zeros means solve, right? So I'm going to choose to solve by factoring if possible. Well, multiplies to be negative 80 and adds up to be 2. 10 times 8, right? Negative 8 to be positive 2?
Yep.
So this factors to be x plus 10 and then x minus 8. Now is that my answer?
No.
No, it didn't say factor. It said solve. So I chose to solve by factoring. So this is because I'm solving, I've got to keep going. The zero product property rule allows me to split them up, set them each equal to 0, and solve. So we get x is equal to negative 10, we'd subtract 10. X is equal to 8, we'd add 8. Am I going to throw away any answers for this one?
No.
No, right? It says, what are the, find the zeros. Those are our zeros.
Oh, no, just, you still have negative 2, right? If you subtracted 10 and added 8.
10 plus negative 8 would be positive 2, right?
It's just, she just quick factor.
Yeah, so then you like to do it the long way, which is great, drop and break and go through, but when you factor, you'll get here. Okay. Next one, it says find the zeros. So once again, we're solving x minus 1 squared minus 9. Now, guys, a times c adds up to be b is a standard form of a quadratic method of solving. Okay, so I'm not going to solve by doing that with this one, because it's not in standard form. Isn't it in vertex form? Okay, so to solve a quadratic in vertex form, we set it equal to 0, and we algebraically solve for x. These are the easiest ones to solve, as long as you don't forget some things.
Plus 9.
Add 9 to both sides. So we have x minus 1 squared is equal to 9. Now we're trying to get x along. It's trapped in the square.
Square root.
The inverse of a square is a square root. That cancels out with that. It's an inverse, so they really undo each other. We have x minus 1 is equal to what?
3. Plus 9.
Way to not forget that, Martin. It's not only 3, it's plus and minus 3. And if you miss that, it would be a huge error. You'd be wrong. So we know that this technically means x minus 1 is equal to positive 3. Look, positive 3. And x minus 1 is equal to negative 3. Split it up. Now solve for x.
4.
Add 1, right? X is equal to negative 2. Do I throw any of those away? Nope. Questions? Okay. We're almost there, guys. This is a problem off your stage review packet, so let's just do it together so you don't have to do as many. Okay, it says, what is the solution of the system of equations? So we have y is equal to x minus 2. Don't we have a line? It's not a line. X minus 2. And then we have y equals x squared minus 8x plus 6. We have a quadratic. Aren't they both equal to y? So then they must be equal to each other. So we have x minus 2. That line must be equal to, if they're both equal to y, then they're equal to each other. So what we're looking for is when does x minus 2 equal x squared minus 8x plus 6. Does everybody understand that? Now we could go through the long way and algebraically solve this because we want to know where they intersect. We could go through algebraically and solve this, but then we have to get this side equal to 0, right? So we could do that, and then we'd solve by the quadratic formula or factoring. However, there's an easier way, and I suggest you use it. Your calculator will do it for you. So pull up your calculator. Go to y equals. In y1, you'll type in the line, x minus 2. And then in y2, we have another function, x squared minus 8x plus 6, what was it? Plus 6. Now you'll hit graph. Now you might have to change your window if you can't see where they intersect. So look, my my line just was graphed. And now my quadratic was just graphed. Does everybody see that? So we're going to say, okay, we know the solutions are when they're equal, which is where they intersect. So it's intersecting in 2 places, so we'll have 2 answers, and we'll write it as xy points. Let's not eyeball it, though. Let's use our tool here. So do second trace. We want to know where they intersect. This is an easy one if you can do it in your calculator, right? So it's really different when you're doing it yourself, so you should all do it. So now it's this first curve. Now you got to pay attention, because see how we're close to this intersection point. The next time we do this, we can't be close to this intersection point, or it will just calculate that same intersection point. So just keep in mind. So we're close to that intersection point, so we hit enter. Now it's on the quadratic, and it's close to that intersection point, so we hit enter again. It says, do you want me to guess? Hit enter again. So it's intersecting at 1, negative 1. So there's one of our solutions. 1, negative 1. Okay, let's do the other intersection point. So you'll have to start over. So you'll do second trace, and now you can't stay in the same spot. You've got to be closer to the other intersection point. So now look, I'm going to scroll over closer to that other intersection point. And as long as you're close, you're good. I hit enter, and it will put the other one close. Enter, enter. So it's intersecting at 8,6. So there's our other solution, guys. 8,6. Look how easy that was. That would be a shame to miss. That was pretty dang easy, right? Questions? Okay, that's all we're doing for stage review for